Okay, so for this one, the best way to think of that is as if it were something different. And that something different would be like x squared minus x equals 20. So if I had this problem, I'd bring the 20 over, get it to 0, so then I could factor and solve. And so we need two things that multiply to be negative 20 and add to be this negative 1 right here. So that'd be a negative 5 and a positive 4. And then from there, we just set each of these equal to 0 and solve. So if I had this, I'd bring that over and x would be 5, and likewise here, x would be negative 4. So this is the same thing. It's not quadratic, but it's in the form of a quadratic, and that is because if I square this, it makes this. So m to the 1/3 squared would be m to the 2/3. And what that means is it's in the form of this, and I can factor it kind of the same way. Whatever is right here in the middle tells you how this thing is going to split up. So over here we had an x in the middle, so it's split up to x's because x times x will make x squared. For this one, it's going to split up to m to the 1/3 and m to the 1/3 because I have to go m to the 1/3, m to the 1/3, and when we multiply, we add the exponents, and that makes our m to the 2/3 up there. But if you just kind of look right there, that tells you how this is going to work. If this had been instead m and then minus square root m equals 20, and I should have subtracted this 20 over. I just realized before I wrote that out, but pretend like I've minus the 20 and now it's equal to 0. But if I had this, I would split that, and same thing, we'll make that minus 20 equals 0. I would split it up to root m, because that's what's in the middle. If this was, 2/5 and this was 4/5, it would be m to the 2/5, m to the 2/5, because 2/5 plus 2/5 would make that 4/5. So whatever's there, that's the key. That's telling you how to get it started for the factoring. And then other than that, you're thinking of it the exact same as this problem. What multiplies to negative 20 adds to be negative 1, so same negative 5 and positive 4. And now we can set those to 0. And solve them. So we'll bring this 5 over. M to the 1/3 equals 5. And since this is a cube root, we would cube both sides, and we could have a cube can equal either a positive or a negative, but if it had been a square root, I'd have to be careful because a square root or any even root wouldn't be able to equal a negative number over on this side. So if this had been an even root, that would be extraneous, but it's not, it's an odd root. So we will cube both sides of this, cube, and so cube undoes cube root, and we get m equals 125, and here cube undoes cube root, so we get m equals, and there's a negative under there, and that's 3 negatives, and that's why we could do this with negatives, is because it comes up negative 64, so that sign is still accounted for. So that is how those go. Again, key is right there. Whatever's in the middle, if it's in the form of a quadratic like this one is, that's how it's going to split. You'll see the same thing next quarter. It'll be things like cosine squared theta minus cosine theta minus 20. And this one is a little nonsensical because it can't be 5 or 4. But it's the same thing. It was split up cosine. So that's the key to those. Hopefully that helps.